Thank you all. Glad to see so many of you today. Before I start, just out of curiosity, how many people are into application security, offensive security, pen testing, exploitation? Cool. Okay, cool. So this is going to be, heads up, is going to be a very technical talk, nothing theoretical, hands-on stuff. So let's start. In case you're interested in these slides, you can scan that QR code and you can get these slides. You can get the Vesta takeover, which is going to be presented to us next week. So yeah, I received these invitations. They're both the same month, 1 week difference between them. So I was like, yeah, I can't present the same stuff. So it's going to be a very different talk, also hands-on, very focused on application security and exploitation and low-level stuff. And you can also get our field application research, which was done by Bogdan over there, which was also very popular research. Yeah, I'm not going to say more. A lot of, let's say, their entire database, all their clients were affected, but we managed to fix all those issues. And you can also check out our entire blog post if you want to see other research that we did. So, a couple of words about myself. My name is Adrian Tiron. I'm a co-founder and principal at Fortbridge. I got a couple of certifications. My favorite ones, you might recognize these, OSCP, OSCP, etc. They're all from offensive security. I'm a big fan of offensive security trainings, as you can probably imagine. And a couple on red teaming and AI as well. And I've also been speaking at quite a few conferences over the past 2 years, like besides Dresden twice, besides Kent, Blue Hat, organized by Microsoft in Israel last year. Besides Budapest, I spoke there last year, and it looks like this year I'll be speaking again there. Pass the Salt and OWASP, of course. Now, what's this talk about? As I mentioned, application security. This is our bread and butter, basically, at Fortbridge. And there are a couple of things that I will address here. We'll be discussing about file uploads, which are always fun, because there are so many things that can go wrong with the file upload, and you can't really catch all the issues that go wrong with file uploads using an automated scanner. So perhaps I should have started with this. I understand most of you are DevOps guys, DevSecOps guys, so you probably set up some automated tools like Dust, SAST in the pipeline. This presentation will show that there are still a couple of vulnerabilities that are normally missed by those scanners, and you will see why in a bit. We will also discuss about a class of vulnerabilities called SSRF, which is very popular for maybe close to a decade now, I would say. Exploitation of SSRF is always very, very context dependent. And I will show how to exploit SSRF in the cloud, in an AWS environment, to be more specific. And then the key of the presentation, I would say, is it's a double race condition. Like you might have seen race condition before, but this one I've not really seen many other references to double race condition. So essentially I found the race condition. In order to exploit it, I basically had to convert it into a double race condition. You will see all the details in a bit, trust me. So the target is called Concrete CMS. We had a London client. They built a careers website on Concrete CMS, and they reached out to us for a pen test. So a couple of words about Concrete CMS. It's written in PHP, which is a language that I'm a big fan of, because I started my career many years ago as a developer. And back then, PHP was notorious for having a lot of security issues. So people love to kick PHP a lot, and they still love to kick PHP a lot. But I would say the situation in general with the PHP language has improved quite a bit over the past 5 to 10 years maybe. But it still has a pretty bad rep, to be honest. This CMS is also used by the US Department of Defense and the US Army. It has a bug bounty on HackerOne. We didn't get any money for this, but we had to reach out to them via HackerOne, and it was a very, very good collaboration with the Portland Labs team. They were very fast in fixing all the issues that we reported to them. We reported quite a few issues to them, but what you'll see today is by far the most interesting one. Yeah, I mentioned all this stuff. So next, what happened?
So I'll go to the next slide.
I'm not sure what's going on. Let me try to refresh. Maybe this will work. Hold on. Let me check if it's still connected to my
Wi-Fi.
So we quite enjoy. No, we don't enjoy it. It's okay having AutoGen not here. It means that I don't have to make sure that everyone's happy and they're happy with what we do in their venue. But it also means that we can't get on their Wi-Fi. So yes, so I managed to get through the intro slides on 5G. We got halfway through, or a little bit less on Adrian's.
Okay, that's fine. I have the slides local.
Yeah.
Yeah, that's fine.
Okay, it's
So, we have the source code. Sorry, thank you. We have the source code, it's available. So I was like, okay, let's do white box. It doesn't make sense to do black box testing for this, and this will also help us to increase our chances to find better vulnerabilities and more impactful. A couple of issues were reported previously on HackerOne, and we also reported quite a few of them, and we received quite a few CVEs for these. So, the first thing that we noticed, there was this form where essentially you could enter a URL, and what the CMS was doing, they were fetching this file from this remote URL and saving it locally. So I was like, cool, let me try a PHP extension, let's see what happens. So what happened was they rejected with an error. So like, oh no, they do validation. I mean, that's nice, that's a good attempt, at least, you know, they were a bit security aware, so they thought, let's do validation on the extension. We will bypass that, and I will show you how in a bit. Obviously, you know, as I mentioned, if you are familiar with SSRF vulnerabilities, this is essentially an SSRF vulnerability by design. From the developer's perspective, they say this is a feature because it allows them to download remote files. Well, as a security engineer, I have a slightly different perspective on it. For me, it's a vulnerability. And as I was looking through HackerOne, it was obvious to me that some of these issues have been exploited previously, and they added some validation. Now we will bypass that validation, of course. I'll show you in a bit. The first thing, or the next thing that I tried, basically, I was like, let's assume the CMS is installed in the cloud, right? And what do you do essentially when you have like an SSRF vulnerability in the cloud? The first thing that you will do, you will try to target the metadata server, which is 169.254, 169.254, and you will try to fetch the IAM credentials, right? So I tried to do that. And I got another error back. They said, no, it's not valid. So like, okay, cool. You've been burned with this before, so you decided to add some validation. Good, very good. So I like, cool. What other things can I do with this SSRF? So I thought at a different scenario. What if this CMS is installed somewhere on a host that is exposed externally? Can I try and target the internal network? So, and the answer is yes, you can. Because I tried to insert internal IPs here, like 192.168, something that I have in my network, and this was accepted. Now, if you're familiar with PHP, PHP developers, what they usually do, they will place a file called info.php or php-info.php, which looks like this download. This is like very common in all PHP environments, just to see that, to test that the environment works okay. Now, as you saw previously, however, the PHP extension is blocked. So I was like, how do I bypass this? Well, it's very simple. If you're familiar with PHP hacking, the way you trick the interpreter is binding a slash, and then you add another file name with a different extension. So in my case, I added, after info.php, I added slash test.html. And their validator looks at it and says, this is HTML extension, I'm going to allow it. Because they think, it's okay to download a remote HTML file. But when the PHP interpreter looks at this, it will see a PHP extension, actually. The PHP interpreter doesn't care about the .html. That's from the PHP interpreter perspective, the test HTML is just some junk added at the end, so it doesn't care. And this is how I bypass the validation on the extension, and this is how essentially you can try and enumerate the internal network. So that's cool. It's interesting, but I still want to exploit in a cloud environment and get the IAM credentials. So how do I do this? I found a solution to that as well. How many of you are familiar with an attack called DNS rebinding? Okay, cool. So there are a few people. Cool. So, what is DNS rebinding? DNS rebinding is a pretty old attack. Essentially, since I control the domain here, right? I control the DNS server for it. And I can create a custom DNS server which changes the IP answer that it replies every time. Because if you think, how does the code look behind this feature? Well, first of all, it does a validation. That is step one. And when it does the validation, my authoritative DNS server will respond with an IP that is allowed. And after it passes the validation, it will do another, let's say, query to the DNS when it will actually try to fetch. So this time, the DNS server will provide an invalid IP, which is the IP of the instance metadata. So it's basically like a race condition or time of check, time of use issue. So I found a service which was already created online by a Russian hacker, I think. It created this hostname, make a valid IP, sorry, and then rebind to an invalid IP. And essentially all I had to do was try 2 or 3 times. That was enough. Try 2 or 3 times, and essentially you bypass the validation with DNS rebinding, and then I got the keys from the IAM instance metadata. This is it. And this is how we exploit this issue in a cloud environment. So I was like, cool, making some nice progress. We looked at how to exploit it in the LAN. We looked at how to exploit it in the cloud. But it's a file upload, and this is a PHP application. So I want more. I want to actually exploit it and get remote code execution on the server. So I was like, let me look at the code. Let me do code review and see how I could get RCE from it. So there was this function which is called download from remote or something. Now if you look at it, it does a validation here on the file name. It checks the extension. It creates a file name here with some random stuff. Then it creates a temporary directory name, and it writes the file. So what you'll notice if you pay attention, between this validation and writing the file. Sorry, the validation is only on the file name. That's it. That's it. And then it strictly writes. It writes the file on the file system. So what's missing from here is the validation from the extension. That is done much later. So essentially what I noticed is happening is this. The file is saved on the system, then the validation on the extension is done. If the validation fails, only then the file is deleted. So we have an issue with the order of operations. The file is first written, then the validation is done on the extension, and when it fails the validation, the file, together with the temporary directory where it was written, they both get deleted. So what it means in practice, this file will be written on the file system for a couple of milliseconds. And this is an issue, because the validation should be done first, and if it fails the validation on the extension, simply don't write it, which is how they fixed it. So the question became, okay, we have the file on the file system, it shouldn't be there, but it's there for a couple of milliseconds. How do I trigger it to trigger some malicious behavior in that small time window? This is the first case condition. So, as I said, the first thing it does in the upload or download, depending on how you look at it, it creates a temporary directory name. The name of the temporary directory is volatile $E concatenated with $E. $E is basically just a counter, which in practice will always be 0, okay? And then it uses the unique ID from PHP, which generates like a pseudo-random number. So unique ID is used to create a temporary directory, and it's not crypto-secure function. Now this is another problem. This is another problem because it's a pseudo-random function which is used in a very sensitive operation. So we'll see why this is bad. So like, excellent. I already knew that unique ID is pseudo-random. The question is, how do we exploit it? So I started digging deeper. How many of you worked with C language before? Cool. So I started having a look in the PHP core, which is written in C, and I found the unique ID functions. Now, don't worry, this code is quite simple. So essentially, this is like a prologue of all PHP functions, which essentially says that the unique ID takes two parameters. One is prefix and one is prefix len. Now, both of these parameters are optional, and if you remember from the previous slide, none of these parameters were passed. Excellent. So what it does next? It uses get time of day. Get time of day, yep, exactly that. Get time of day essentially returns the current second and the microsecond. Then at the end, it does a check if more entropy. More entropy, there's no more entropy because this parameter was not used, okay? So essentially, it returns, there's no prefix, there's no seed, it only needs the second and the microsecond, which it converts into hexadecimal format. So essentially, it all comes down to getting the current second and the current microsecond, and if you have these, you can predict unique ID, and if you can predict unique ID, basically you just found the name of the temporary directory where the malicious file will be stored. That's it. Now, in case some of you may not be familiar, the problem with using time is that it's deterministic and it's brute forceable. So using time or microseconds, it's always a bad idea in sensitive operations. Also, in case you're not familiar, the current timestamp, you can get it from the response headers. That always gets leaked. That's also a known trick, right? So we'll get the timestamp from the response headers, and the only remaining thing is to brute force the microsecond. And that's just 1 million values. That's like 20 bits of entropy. It's not that much. It is very brute forceable. So I thought of a plan. Okay. So, the first step, we need to find the name of the temporary directory where the file is written. So basically second and microsecond. So for this, we need to make sure that the file that we download from an attacker-controlled server will execute a sleep for some number of seconds, because I will fetch a remote file, right? This file needs to execute for like 35, 40 seconds minimum in practice. That's what I discovered. While this remote file sleeps, I am brute forcing the name of the directory, or brute forcing the microseconds basically. And in order to do this, I will use a tool called Turbo Intruder. I don't know if you're familiar with Burp Suite. It's a proxy that we use for web application testing. And there is a very good extension we use, Turbo Intruder, which is created by a very smart guy called James Kettle. And essentially, you use Turbo Intruder when you need like extra speed to brute force stuff. So it's perfect for this scenario. When the author released it, he said that it was designed to make the billion requests possible. I don't need a billion. I need more like at least 500,000 to 600,000 works in practice. So that's much less than a billion. Then our downloaded file plus temporary directory will get deleted when the application realizes that we failed the validation. So what we'll have to do, we'll have to find another solution here to write a permanent shell to give us persistent on the server. We'll do that as well. So the question is, again, how do we trigger our downloaded file before it gets deleted? This is the second race condition. So, this is the temporary shell. Now this is like 6 lines of PHP code, which is not a lot, but in practice it actually took me quite a bit of time to come up with these 6 lines of code. I swear it took me a lot of time to debug. So this will be hosted on the remote, on the attacker server, right? And on the victim server, you will use the URL to this file. So what does it do? First thing it does, set time limit 0, because in PHP by default, every script gets killed after 30 seconds. So I want this to run for more than 30 seconds. Between 30 seconds to a minute. You will see why in a bit. I only have like 30 to 60 seconds to exploit this. After that, it does a sleep 35 seconds. As I said, one more time, this sleep 35 is necessary to give me time to brute force the name of the temporary directory. And then, if you look here, this is the key. When this PHP script gets executed, it outputs another PHP script. Now this is the permanent shell. What this does is, it does a file put contents. In the parent directory, it writes my permanent shell, which is a simple PHP backdoor. That's it. It outputs, and when this will execute it, it will write the permanent shell in the parent directory. That directory doesn't get deleted, it stays there forever. And then it's added some random A's simply for output buffering purposes. I did some debugging and they were necessary, simply they were necessary, so that's why it's there. So, I made a diagram here to help with visualization. This is the timeline of the race condition. So at T0, right, we start searching for the volatile directory name. We have the timestamp from the response headers. We're simply going to start to brute force the microseconds. At T1, which will be somewhere between 0 to 35 seconds, we will have found the temporary directory name. Now this could be 5 seconds into this 35 seconds window, or it could be 15 seconds into this window. We don't know exactly. So at some point we will find this temporary directory. After that, we'll have to start looking for the PHP script inside this directory. So we will queue another, in practice, we will queue another 500,000 of requests, which will send a lot of GET requests to a file which I named test.php. So test.php is the previous file that you saw. you saw, right? So I'm trying to hit this continually. I don't know when it will be there, so that's why I'm queuing another 500,000 of requests. I'm sending a lot of GET requests to trigger it at some point. Now, once I found this test PHP file, or the temporary shell inside the directory, once I found it and I execute it, the permanent shell gets written in the parent directory. And then the validation happens, they both get deleted, but I have my permanent shell in the parent directory. So here is essentially the same thing. I just explained everything in words, so I'll go through it one more time in case somebody didn't understand something. And I will also add some numbers to it so you can see the numbers that I had to use in practice. At T0, we start the upload, and we also start searching for the volatile directory name. We have 1 million possibilities because there are 1 million microseconds, and in practice, I was able to send about 16 to 17,000 requests per second over HTTP2. This is very important. HTTP2 is very useful for speed. It's much faster than HTTP1. So with these numbers, I can easily brute force about 500,000 to 700,000 in about 30 seconds, which gives me a probability of more than 50%, which is very good. Works really well in practice. I didn't queue a whole 1 million requests because there was some issues with Turbo Intruder, but also it wasn't necessary because from my perspective, an exploitatory force with 50–60% chance is perfect. It's more than enough, really. At T1, we discovered the volatile directory name, so I won the first race, but the temporary shell isn't there yet, so I will have to start searching for the temporary shell, second race, and that will always be written after about 30 or 35 seconds from the moment I started. And as I said, I queued another 500,000 of requests in Turbo Intruder for this. At T2, this temporary shell is written locally inside the volatile directory. At T3, one of the queue requests from here will hit the temporary shell and will write a permanent shell in the parent directory. At T4, they get deleted, but I already have my persistent shell. And here you can see a screenshot from Burp. You can see that I found the temporary directory. Volatile, looks like volatile-0 and a few hex digits, which is basically the output of unique ID. And it returned here a 200 code. Again, yeah, everything's there. Here, you can see that I took a screenshot from access log while I'm queuing 500,000 of requests to search for my temporary shell. A lot of them return 404, but we don't care about that. I only care about the one that returns 200. Right? And this is our second race. And this is, I guess, what we're all looking for. Yeah, I got code execution. It executes as dub data, and it wrote shell PHP in the parent folder. Looks good? Yeah. A couple of debugging tips. If you remember, I said that the maximum that I could sleep in that temporary shell is 60 seconds. Why is it 60 seconds? Because they are using curl behind it, and curl has a timeout of 60 seconds, right? So I can't force it more than 60 seconds. So between 30 and 60 seconds, that's the time where I need to do all this stuff. Like I said, use HTTP2. There was a lot of debugging in creating this exploit, so that's why I used a lot of tailf for access log and for error log. Error log, why was this useful? At some point, I don't know why, I was testing this from 2 machines, and it wasn't working. And then I realized they were doing a check in the session that if the IP changed, they were invalidating my session. So that was also a problem. So that's why this note is here, like everything needs to be run from the same machine. And of course, when you send your request to Turbo Intruder, you need to make sure that the session there is valid, right? So these are all issues that I experienced the hard way. Solution, upgrade to the latest version. We reported many issues. We received a lot of CVs. But like I said, this was by far the really most interesting one from an exploitation perspective. That's why we're doing this talk today. Questions?
You good? Thank you, Adrian. There is one quick question if anyone has one for Adrian. You go on then, Sam.
Great talk, Adrian. Very interesting point about the fact that they revalidate the session, because my first thing was because you use the fact that you could squeeze so many requests per second to find the name of the temporary folder.
Yep.
But very interesting situation here might be if they were rate limiting the requests from and bind it to IP address.
Yeah.
Did you think about that scenario? Did you have like a plan B if the requests are limited?
If the requests, if the requests are limited, they weren't doing that, but I agree with you, like, it's always a good idea to apply rate limiting, especially from a defense in depth perspective. Now, I see people implementing rate limiting sometimes, but I wouldn't say, to be honest, that that I've seen them implementing on endpoints like this. So I see them usually implementing rate limiting maybe on stuff like login, password reset. On stuff like this, I don't really remember seeing it everywhere, but that's a good point. And to answer your question, if they would have implemented rate limiting, it depends on how they implement it. So for example, if they implement rate limiting per IP, in that case you could go and do some IP rotation. You can maybe use an AWS service or some cloud service to do IP rotation. If they do rate limiting based on user, that's also sometimes it's exploitable, I think, with race conditions sometimes. So, and I had access to the source code. Just to mention that again, okay? So if it would have been implemented in source code, I would have reviewed that as well. Like I would still have tried to find a way around it. Yeah. Hope that answers your question.
Excellent stuff. Big round of applause for Adrian. Thank you. So this is meetup number 98 for London DevOps.